Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 56, Security Testing in Your Development Process. Alice, we've been through monitoring, incident response, disaster recovery. Now we're closing the loop. How do you find the vulnerabilities before the attackers do?
And the keyword is before. If your security testing happens once a year in a penetration test, you're finding bugs 364 days too late. Every vulnerability that exists in production between pen tests is one an attacker can exploit. The modern approach is continuous security testing, embedded in your development process, running on every code change, catching different types of issues at different stages.
So walk me through the layers. Where does it start?
Start at the very bottom, pre-commit secret scanning. Before code even reaches your version control system, a hook, an automated script that runs before the commit is saved, scans for accidental secrets, API keys, database passwords, tokens. We covered this back in episode 52 with the day zero checklist. This is your first line of defense against the most common mistake developers make.
Right, and then what runs in the CI pipeline?
Two things run on every pull request. First, SAST, Static Application Security Testing. These are tools that examine your source code without running it, looking for patterns that indicate vulnerabilities. SQL injection patterns, where someone builds a database query by concatenating strings instead of using parameterized queries. XSS patterns, where user input gets rendered without escaping. Insecure cryptographic operations. Tools like SendGree and CodeQL can catch these as the developer writes the code. Some even run in the editor, flagging issues in real time.
And the second thing?
Dependency scanning, also called software composition analysis or SCA. Every third-party library in your application is code you didn't write and might contain known vulnerabilities. SCA tools check your dependency list against vulnerability databases. NPM audit, pip audit, SNLike, Dependabot, they all do versions of this. Configure your pipeline to fail the build when a dependency has a known critical or high severity vulnerability. A red build forces the team to address it before deployment.
Yeah, we talked about hallucinated packages in episode 51. This catches those too.
It catches known vulnerable real packages. For hallucinated packages, the slop squatting risk, you need the private registry approach we discussed. But SCA catches the other half of the AI code risk, when the AI suggests a real package in a vulnerable version. Combined with a locked dependency file, you get comprehensive supply chain protection.
So SAST looks at code, SCA looks at dependencies. What about the running application?
That's DAST, Dynamic Application Security Testing. DAST tests your running application from the outside, like an automated attacker. It sends crafted requests and analyses as responses. Where SAST finds this code builds a SQL query unsafely, DAST finds this endpoint actually returns data it shouldn't when I manipulate the request. It catches authentication bypasses, security header misconfigurations, information leakage and error messages, core S issues, things that only manifest when the full application is running.
And you run that against staging, not production.
Against staging? A copy of your application that mirrors production but uses test data. Run it on every deployment to staging. OWASP Zap is a solid open source option. Burp Suite is the commercial standard. The key is that SAST and DAST find different things. Some vulnerabilities are invisible in the code but obvious in the running application. Some are obvious in the code but can't be triggered in a running test. Using both gives you complementary coverage.
Right. Now, all of that is automated. Where does manual testing come in?
Manual testing, penetration testing, is where you find the things automation can't. Business logic flaws, complex multi-step attack chains. The scenario where an attacker creates two accounts, uses one to invite the other to a case, then exploits a permission gap that only exists during the invitation flow. No automated scanner is going to find that. A skilled pen tester will.
How often should a legal SaaS platform do pen tests?
annually at minimum. Plus, after any major architectural change, a new authentication system, a new data storage layer, a new API surface. For platforms handling highly sensitive data like active litigation strategy, semi-annual, and scope it carefully. For legal SaaS, the critical targets are tenant isolation. Can firm A's users access firm B's data, authentication and session management, API access controls, file upload and document processing. These are where the highest impact vulnerabilities live.
And what do you do with the findings?
A pen test report is a to-do list, not a trophy. Prioritized by severity and exploitability. Critical and high findings get fixed before the next deployment. Medium within 30 days. Track every finding to resolution and retest to verify the fixes work. And here's the crucial step most teams skip. For every vulnerability found, write an automated regression test. A test that reproduces the vulnerability, fails before the fix, passes after, and runs on every pull request forever.
Yeah, so the bug can never come back.
Exactly. Over time, you build a growing library of security-specific regression tests. Think of it as your application's immune system. Every infection it survives makes it stronger. The pen tester finds an IDOR vulnerability. Someone can access another firm's case documents by changing the ID in the URL. You fix it. You write a test. Authenticate as user A from firm A. Request a document belonging to firm B. Assert 403 forbidden. That test runs on every pull request. If anyone refactors the access control code and accidentally removes the tenant check, the test catches it immediately.
What about bug bounties? When does a legal SaaS team start one of those?
Not on day one. Start a bug bounty after you have automated testing in CI, at least one pen test completed, and a process for triaging and fixing reports. A bug bounty before those basics just generates a flood of reports you can't handle. When you're ready, platforms like HackerOne and BugCrowd provide managed programs with triage support and legal safe harbor for researchers. For legal SaaS, the bounty scope must explicitly exclude access to real client data. Use a dedicated testing environment with synthetic data.
Right, so to sum up the layers, pre-commit secret scanning on every commit, SAST and dependency scanning on every pull request, DAST on every deployment to staging, manual code review for security critical changes, pen tests annually, and regression tests that grow with every bug found.
That's the security testing pyramid. Lots of cheap, fast, automated checks at the base. Fewer, deeper manual reviews in the middle. Rare, comprehensive expert assessments at the top. The automated layer prevents the pen test from finding the same things twice. The pen test finds what automation can't see, and regression tests ensure that nothing ever comes back. It's not a phase of development. It's a layer that runs continuously.
Next episode, access reviews and least privilege audits. That contractor who left 6 months ago, their API key is probably still active.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.